My name is Sverre, and I'm a Senior Director of Engineering on the Launchpad team. One of the best parts of my job is building applications which showcase the unique and interesting capabilities of SingleStoreDB. So when I was asked to build a demo for the launch event, I was stoked. I think the conversation went something like this. Hey Carl, can you make a demo for the 7.9 launch event? No problem. How does a universe simulation sound? Just imagine thousands of solar systems full of millions of spaceships. Okay, I get really excited about universe simulations, but luckily Raj said yes, and we were off to the races. So we had an idea. And as I was saying, the idea of thousands of solar systems and millions of spaceships flying around a virtual universe just sounds really compelling. But could you build it using only a database? Could we use one database to do everything needed to power this entire simulation? Well, you'd need a couple of pretty hard features in such a database. The first one is you'd need to be able to handle transactions and analytics at scale. At the very least, to simulate this universe that I have in mind, we'll require over 1 million transactions per second, or more specifically, 1 million update operations per second. And that's just to move the ships around and let them react to their environment. So transactions are going to be extremely important. But while those transactions are happening, we're going to need to run a lot of analytics to be able to render the game UIs and make them look super cool. And speaking of game UIs, well, I don't want to just power one game client. I want to be able to power thousands of game clients, which means that we need all of those analytics to run with high concurrency. So this is just yet another hard problem to stack on top of an already really hard problem. And finally, we would need to be able to extend the database with custom logic. I want my spaceships to have behavior. I want them to have AI, and I want them to be able to react to their environment in a semi-believable way. And for that, I want to write behavior or an AI for these spaceships in a higher level language so I can leverage open source libraries and just use all the tools that I'm used to as a software engineer. So these are my requirements for building a universe simulation. And before SingleStore 7.9 came out, I didn't have all of these things in one database, but now I do. So I'm introducing the Wasm Space Program. Let's go check it out. This is the universe. The universe is full of solar systems. Each of these yellow symbols on your screen is a solar system. Currently, there's about 32,000 solar systems in the simulation. And within all of these solar systems is about 1 million spaceships. So we have a live universe that is running in real time. We can see that the current turn time is about 755 milliseconds. As long as that's less than once per second, we are in real time. Everything is running and able to synchronize across our workspaces without any problem. So what we can do here is we can jump into a solar system to see what is happening inside. I'm going to do that right now. So in a solar system, we have a couple of new symbols. These symbols here, the ones that look like asteroids with little green bits sticking out, they are called energy nodes. You can think of an energy node like a phone charger. Spaceships will show up and essentially try to consume energy nodes. And by doing so, they will charge up. And so spaceships, when they're charging, is really good because spaceships need energy to survive. We can see a spaceship over here running around and trying to consume energy. However, spaceships are interesting because spaceships have behaviors. They aren't just dumb spaceships. They actually look at the universe around them and they decide what to do. And this particular spaceship is trying to get energy nodes that are safe. It's only basically going after energy nodes that are not being actively sort of hunted by other spaceships. And as another spaceship approaches this spaceship, it will likely run away. As you can see, it just happened right there. So we have energy nodes, we have spaceships, and they all are basically living their best lives in this virtual universe. The cool thing about this is that all of these solar systems are being simulated at the same time. So I can go anywhere in this universe and see something interesting happening. For example, there's a battle happening right here. These two ships are actually fighting over an energy node. They both want access to it because of the energy that it represents. And if we look at the battle, we see that I would go ahead and guess that this ship is going to win. But you never know. This is an open spaceship, open universe, and at any point another ship could just show up and disrupt this battle and change the outcome. I love simulations like this because they're full of emergent complexity. I have no way of predicting what is happening in this universe. I can only look and observe and see what these ships are deciding to do. So that's a quick overview of the Wasm Space Program. Let's talk about the architecture next. This is the architecture diagram. I want to draw your eye to 3 different areas of the diagram. On the right side, over here, we have our storage. The middle, we have our compute, and on the left side, we have our client. Let's start with storage. As I said at the beginning, the goal of this demo was to run the entire demo inside of SingleStore. So use SingleStore for as much of the compute and storage as possible. So on the right side, we have a database, which is in the SingleStore cloud, and the database is continuously backed up to object storage. This allows the database to be connected to from multiple workspaces, and all the workspaces can see the exact same data as it changes. In the middle, we have our workspaces. This is the compute of our simulation. Most of the compute happens in the writer workspace. The writer workspace is responsible for running each turn. Each turn is a single store procedure in SingleStore, and the store procedure runs in one massive transaction over 2.5 million update queries. Those update queries are really interesting. In addition to changing the data 2.5 million times a second, we're also running Wasm, basically Rust code compiled to Wasm and added to SingleStore. So I wrote the Spaceship AIs in Rust, I compiled it to Wasm, and I added it to SingleStore as a new function type. So those 2.5 million update operations are actually running those functions that I defined as part of that transaction. And that's what makes this entire simulation feel alive. In total, during each turn, we run Wasm functions over 6 million times. That all has to happen consistently. So to make sure that no other workloads can affect the turns running every single second on the dot, we split up the workload between the writer workspace, which is this first one here in the middle, and the reader workspaces, which are the additional workspaces below. These reader workspaces have access to the exact same data as the writer workspace and can see it as soon as the writer workspace changes the data. So as those transactions are running, that data is immediately available. But we are guaranteed that no matter how heavy the read workload is, we can't negatively impact the writer workload. And that's really important when you want something to happen consistently at a certain time scale. So we have our reader workspaces, which is where we run our read workload. And we have our game clients. How do they connect to each other? The game clients use our data API, which uses HTTP to connect directly from the web browser to each of the read workspaces and run queries. The game clients are written in JavaScript and are a relatively lightweight client. They send queries to the server and they get some response and then they render it in the pretty way that you've been seeing. And that's pretty much it. That's how you build a universe simulation in one database. I've been working at SingleStore for over 9 years. And I've seen a lot of innovative technology at SingleStore over the years, and I love our database. But I gotta say, SingleStore 7.9 feels revolutionary. It's the first time I've been able to extend SingleStore with custom logic written in my favorite languages. And being able to do that and combining that with the power of SingleStore with huge amounts of transactions and analytics, massive concurrency, is just amazing. It changes how I think about building applications. I can honestly say that I've had so much fun working on this demo and building this universe and making it feel alive. I hope you had as much fun as I had building it, watching the demo. And I hope you go and take a look at it. It's available on GitHub. The source code's all there, so you can see how I built it and all of my mistakes, all the things I did wrong, everything I did right. You could sort of follow my story. And you can also run it yourself. So definitely take a look at that. In addition, there will be some follow-up videos that go into detail on the different features that I mentioned. Thank you so much for your time. I hope you enjoyed this. Have a great day.